Okay, so this is going to be kind of a review from Chapter 2 as well. When we're talking about like a table, and I wanted to make one that was given to you. Erie Community College considers a student full-time if they're taking 12 or more credit hours up to 18 credit hours. So I made a little chart, and I made 12 credit hours, 13, 14, 15, 16, 17, 18 credit hours, and the probability that a student lands in there as calculated from the Erie Community College data. So the probability that someone's only taking 12 credit hours is 0.25. The highest one is 15 credit hours, 0.3. And the reason these ones might actually be higher is because more classes, the majority of classes are actually multiples of 3. So like one class is usually considered 3 credit hours. Occasionally you'll get a 4 credit hour class, which would bring you up to like 13 credit hours. Or 2 4 credit hour classes, which would bring up to 14 if you were taking 2 4 credits and 2 3 credit hour classes. But that might be why those are a little bit higher of probability. So I would like to give you actually the mean and everything. If we were to calculate the mean, and you could do this by hand, it would work out to about 14.65 credit hours. And the standard deviation, I'm going to give that to you as well, 2.06. So give or take about 2.06 credit hours. That's not what I want you to calculate. That was Chapter 6.1. Chapter 6.2 is saying what happens if it's, let's say, $50 a credit hour. Can you make a new table? And let's make it T equals the tuition charge for a full-time student. So technically, a 1 credit hour would be $50. 3 credit hours would be $150. So technically, we're doing 50 times X to calculate what the T is. And our table would look very similar. But for 12 credit hours, now we're thinking of T, which is our tuition, the payment that would be charged. 12 times 50 is about $600. 13 would be $650, $700, $750, $800, $850, and $900, all the way up to 18 credit hours. Now think about the probability. Would the probability change? The amount of people paying $600 is going to be still about 0.25% of the people, or I'm sorry, 25% of the people. We're still going to have the same numbers in here. Now my question to you is, what's going to be the impact on the mean? And I'm going to put mean of T. Now, if it was 14.65 credit hours before, I could calculate it by doing 600 times 0.25, 650 times 0.10. But technically, if my mean was 14.65 credit hours times $50, about $103. So some of the rules from before that we were learning, and this is, I'm going to copy right down from Chapter 2. Effect of multiplying or dividing by a constant. And we wrote in summary, all data calculations are increased or decreased if it were negative, or if we were dividing by that amount. And this means the mean would be multiplied by that amount. The max, the min we had written before. The median, quartile 1, quartile 3, standard deviation. Interquartile range. Keep in mind that the range, the standard deviation, and the interquartile range are all positive values. So we would always want to figure out what those are, and then they would be multiplied by that constant. And they'd have to be positive. So if you're multiplying by 50, you'd want to make sure that you're multiplying by positive 50. Regardless of multiplying by positive 50 or negative 50, you would always want to do the absolute value of that constant so that these values would still remain positive because they are showing distance. It does not change the shape of the distribution. I mean, technically we could look up here and you've got 12, 15, 18. It could be, 600, 750, 900, something like that. And it would look exactly the same. Granted, if you were to do it along the same scale, it would be much more spread out. But you could also kind of just replace these numbers with these altered numbers multiplied by 50 and get the same type of shape of the distribution. But again, it could be more spread out if you wanted to do it along the same type of, where this is 12, 13, 14, 15, 16, 17, 18. Granted, when you go to put this in, it'd be 600. There'd be a lot of numbers here to get to 750 and a lot of numbers to get to 900. But technically, the shape of the distribution is going to remain the same. So let's do an example where, let's say, at ECC, a fee of $100 is added to the tuition for an overall cost of C. So technically, to find C, we would take whatever the tuition was and we'd have to add to it $100. So my chart would look a little bit different. It would have $700 in it, and $750, and $800, and it would go all the way up to $1,000. Now my probability is going to maintain the same, 0.25, 0.10, 0.05, all the way up to 0.15 here, and this would be my C in my probability. And what would happen, do you think, to my mean and my standard deviation? So if my mean before was $732.50, I'm assuming that everyone's going to be paying an average now of $832.50. And if the standard deviation was $103, so give or take $103, I believe that would maintain the same. I don't think we would be adding $100 to it. I think your standard deviation would actually remain the same. Because when you think about it, everybody's being affected by that $100. So now the difference between everybody, it's not going to be give or take $200 between them. Seems like to me it would stay $103. And if we look back on the effect of adding or subtracting by a constant, I'll write that on the next page. The effect of adding or subtracting a constant, the things that would increase by that constant are the mean, the minimum, the maximum, quartile 1, quartile 3, and the median. What does not change is the standard deviation, and that's what we were just talking about. 103 would remain the same. Interquartile range, the actual range from the highest to the lowest. And also the shape does not change by adding or subtracting a constant. It just is, if it was centered at 850 before, then if you add 100 to it, it would be centered at 950. But the actual curves and everything, the exact size of it actually would remain exactly the same. It would just be all the scale at the bottom would be 100 greater.